Now, at this stage, your developer instincts should be tingling because we've created this entire app with just a single file, viewcontroller.swift, and all of our functionality, all of the components are living and sharing this tiny space of one file. So given that in the advanced section of our Swift tutorials, we're talking a lot about architecture and design patterns so that our app is well organized and extensible, then we should really be thinking about applying MVC, or the model view controller pattern, to our app. So let's go ahead and do that. As a challenge, can you create a new Swift file to create a separate class? And inside that class, we're going to put in all of the calculation logic that's currently inside the view controller. So create a new class called calculator logic and put that into a new Swift file. All right, so this is pretty easy. We're just going to select the folder and I'm going to hit Command N to bring up the shortcut for creating a new file. And we're inside iOS Swift file. So if you're ever confused about whether if you should create a new Cocoa Touch class or if you want to use a new Swift file, then remember that whenever you want to subclass something such as a UI view controller, a UI table view controller, a UI view, whatever it may be, then you're going to choose this one. But when you create your own custom classes, then you're going to be choosing a boggled standard Swift file. So let's hit next and let's call this file calculator logic. And I'm going to move it right up close to my view controller. Now at this stage, I'm going to separate it out into MVC. So I'm going to right click on my calculator logic file and I'm going to select new group from selection so that I can put it inside my model file. And then I'm going to do the same with my view controller, and that is going to be my controller. And my main.storyboard is going to be placed inside a view folder. So now I have MVC, and we're going to go into our model and create a brand new Swift class. Now the class name is going to be the same as the name of the file, which is good programming practice. So that way, when you look inside your file inspector over here, you can see at a glance all of the classes that you have included in your project. Now, my class is not going to inherit from any other superclass, so I'm just going to delete that placeholder. And there we have it. We have our brand new class, and we've separated all of our files into the MVC structure. Now, the next part you'll notice is that here I'm importing Foundation, which is a library of code that includes all of the Swift code. But if you look inside viewcontroller.swift, you can see I'm importing UIKit. Now, this includes everything that's inside Foundation, but it also has a whole bunch of UI related things, such as UI view controller or a UI label. Basically, every class that has UI to begin with it is inside UIKit, and you'll need to import UIKit if you need to work with the user interface. Now, in our calculator logic, we don't need to do any of that, so Foundation is perfectly fine. Now, the next step is we want to move all of this calculation related code into our brand new calculator logic model. So see if you can complete this as a challenge. See if you can move all of this into our calculator logic and make sure that it still works when you test the app. All right, so first things first, let's create a new function over here and let's call it calculate. Now, this calculate function is going to take a single parameter, which is called symbol, and it's going to be in the form of a string. Now, my calculate function is where I'm going to transplant all of this code over. Now, you might think that you can just transplant everything, including the iflet, but let me show you what happens when we do that. So if you ever want to refresh the app when your errors are not occurring, then just try and hit Command B, and all the errors that are not meant to be there should be cleared, and the errors that are meant to be there will show up. So the first issue we have is use of unresolved identifier sender. And the problem is that that sender variable comes from this input here. and it refers to the button that triggered the IB action. So there is no such thing as sender over here. So we have to make sure that we actually keep the iflet over here inside our view controller, right here. So we can't actually transplant that part over because we don't have an IB action with a button that's going to act as the sender, giving us the information about which button got tapped by the user. However, if the calc button gets pressed, then we can check to see if sender.currentTitle is not nil, and in that case, we'll bind it to something called calc method. And that is what we're going to pass over to our calculator logic. So we have one extra bracket down here because previously I deleted the iflet. So make sure that we delete the bottom one as well. Now, the next step is you can see that there's quite a few of use of unresolved identifiers. And the thing that it doesn't know about is this thing called calc method. Well, inside this function, we've decided to call the calc method a symbol. So we need to replace all the instances where we've got calc method with symbol. So you can go ahead and hit Command F to find this thing called calc method in this file. And if you click the drop down, we can give it some replacement text, and we'll instead replace it with symbol. So let's replace that one, and that one. And now those errors will go away because we're going to pass in the calc method as a symbol parameter, and then we're going to check against that symbol inside this function. The next one that it doesn't recognize is this thing called display value. And if you remember, display value was our computed property up here, and we figured out what the value of it is by looking into the display label and getting the current value. Now, we don't have a display label over here, and we don't have a display value either. So we're going to have to create a new property inside this class, and we'll just call it something simple like number. And this is going to be of type double, and it's not going to have a value until we pass it over from the view controller. So we can either set this to a optional double, or as you can see, if I want to leave it as this, then it tells me that I have to initialize number when we create a new object from this class. So that means I have to add some init code. So I could say something like init number, which is going to be a double, and inside the init, I'm going to tap into self.number. Now, whenever you're using properties or methods associated with the current class, so in this case, calculator logic, you can refer to the properties and methods with this keyword self in front of it. This means that we're looking inside the current class for something called number. And when you start typing number, you can see that in the left-hand side, we've got this V here. And this is telling us that this is a global variable. So if I hit enter, then I'm saying self.number, namely this property, should equal number, and that number is going to be passed in when calculator logic gets initialized. And when I select it, you can see it's got a L symbol next to it, which means that it's a local variable, which refers to this number. So while I can easily just write number equals number, and it sort of makes sense, right? We're saying this left-hand side is this one. We're trying to set it to equal this one, which is going to be the number that gets passed in through the init. Now, unfortunately, that does not make very much sense to either a human or the computer, because even though they're named exactly the same, it's very, very confusing which one you're trying to set and which one you're trying to get. Now, one way of solving this is to simply make your global and local variables have different names, because then you could say number equals n, and that's a lot clearer what it is that you're trying to change and what it is you're trying to grab the value for. Now, another way of addressing this is simply by adding the keyword self in front of the property. So in this case, this is the property, and we're saying self, namely in this current class, find a property called number, and there it is, and set it to equal the local version of number. So that is what the keyword self is for. It always refers to the current class, whatever it is that we're within. So now we have a way of passing in a number to calculate We have a function that performs the calculation, and all we need now is just a way of giving the result back. And the result is probably going to be in the format of a double. So we can fix these 3 lines of code that currently have errors to instead return the number multiplied by -1. So that means that if the user taps a 6 and then taps the plus/minus sign, then that 6 will get passed in as the number, and the plus or minus sign gets passed into this function. And if that is true, then we're going to return 6 multiplied by -1 as the output of this function. So pause the video and go ahead and fix the last 2 lines. All right, so it's pretty easy. We just have to follow the format that we had before. So if they tapped on the AC button, then they simply want to change the display to 0. So we'll just return the number 0. And if they've tapped on the percentage button, then the result should be the number multiplied by 0.01. Now, once you get to the bottom here, it tells you that there's an error, missing return in a function expected to return double. Well, you might say that I've got loads of returns here, right? I've got return this, return that, return that. But notice how we have a if statement and 2 else if statements. There is still a possibility that we get a symbol passed in here that is not plus/minus, not AC, or the percentage sign. So in that case, then this function doesn't actually return anything. And so what we need to do is right at the end, if none of these other cases catches it, then we're simply going to return nil. Now, the next problem is that this function expects us to return a double, right? And that's not an optional double, that's just a normal double. So it can't ever be nil. So in order to be able to return nil, then we have to change this into an optional double. So there might be certain cases where we pass in a number and we try to perform a calculation on it that doesn't actually match any of the existing cases that we've addressed. So in that case, we're simply going to return nil and we'll end up with a optional, and we'll deal with that optional on the other side inside the viewController.swift. So now that we've got our number as well as our calculate function done inside our calculator logic class, we can head back to our view controller and call that function. So inside this iflet, if we actually have a title inside the button that triggered the calc button pressed IB action, then we need to have a new instance of the calculator. So let's create that here. I'm going to create a new let constant called calculator, and it's going to be a new instance of our class calculator logic. And when I try to initialize it, you can see that it's expecting a number to be passed in. And that number is going to be our display value. And so when I create my brand new calculator, then this calculator logic object will be able to have its number property initialized to whatever it is that I pass in here. And then the next step is to call the function that we created inside that object, which was called calculate. So calculator.calculate. And the symbol that we want to pass over is this calc method, because that is equal to the current title of the sender. So let's go ahead and add that in here. And this, remember, has a output. And this is what this little warning is telling you. Result of call to calculate is unused. So what should we do with the result of the calculation? Well, we're going to assign it to our display value. And we're going to set our display value to the calculation result. And remember, we have a did set in here. So whenever we set this display value, then the value will populate our display label. Now, the final thing we need to address is that, do you remember how we made the output of our calculate function a optional double? Well, we have to deal with the situation where that might be nil, right? So we can simply add in a guard statement, and we can say guard let result equal calculator.calculate with this symbol. And if this fails, namely if the result was nil, then we're going to throw a fatal error, and we're going to say the result of the calculation is nil, so that we can debug it if necessary. And now we can set our display value to result, which is now a unwrapped double instead of what it used to be, which was a optional double. So let's run our app now and see if that did what we expected it to. All right, so let's try this with some numbers. Let's say 1.2 plus minus becomes minus 1.2, and percentage becomes 0.012, and then AC sets it back to 0. So our code seems to be working just fine. But as we're on the advanced Swift section, it's a good time to think about our app's architecture. Up till now in the course, we've been creating classes for all of our models in our MVC. And this works just fine and makes our code comply with the model view controller design pattern that Apple is so fond of. But we can actually make our code a lot safer by simply changing our class into a struct. Now, to create a struct, which is short for a Swift structure, all we have to do is change this keyword from class to struct, and this will turn it into a structure. Now, for those of you guys who have worked with other programming languages, for example, C or C++, or even Objective-C, you'll think of structs as simply just a way of organizing little bits of data, just simply a way of grouping interrelated small pieces of data together into a structure. But structs in Swift is a little bit different. And over the years, Swift structures have morphed and changed many, many times. And with every iteration of the language, they've actually added more capabilities, more functionality to these structures, to the point where we are right now, where they're essentially as capable as any class. And they're no longer these little structures that just groups a little bit of data together. They're very much first-class citizens. You can create properties inside structures, you can create functions inside structures, and they can be used absolutely anywhere, especially for your data models. Now, if you look inside the Swift standard library, and you look at their definition for a string, for example, you can see that it's actually a struct. And so is a double, and so are many, many other things that we've grown to rely on in Swift. So let's take a deeper dive into Swift structures and compare them against the classes that we now know and love, and see when we should be using a struct versus a class, and what are the pros and cons of each.